So now, this week I collected 18 gallons of stale gasoline from a rusting barrel behind a motorcycle repair shop that had gone out of business. And so that rusting barrel was going to rust through eventually, and that stale gasoline was going to eventually empty out into the street, which means it would end up in the water table. So instead of allowing that to happen, I pumped out the barrel to save the community from contamination. And now what I'm going to do with the stale gasoline is I'm going to measure its specific gravity and its viscosity. And this is just a 1 gallon sample that of that 18 gallons. So I've nearly filled the graduated cylinder with the stale gasoline, so I have plenty of room for the hydrometer. So now let's try the 850, let's see, wait a minute, 0.8 to 0.85 hydrometer, because diesel fuel is supposed to be, was measured out at 0.843. So let's see what this comes out to be. It almost tops out, but it looks like it's going to end up being 0.81. All right, so now let's test its viscosity with the number 0 orifice. All right, I measured out at 28 seconds. So it's a little less viscous than diesel fuel. So I've looked at the numbers of this stale gasoline, and it is pretty close to diesel fuel, but it's just a little less viscous than diesel fuel, and its specific gravity is pretty far off actually from diesel fuel. So what I'm going to do is I'm going to try just blending about 10% vegetable oil with this stale gasoline, mainly because right now all I have is waste vegetable oil. I don't have any waste motor oil to experiment with. So I'm going to blend it at just 10% oil to 90% waste gasoline, and then we'll test its viscosity and its specific gravity. But what I'm going to do is I'm going to run this graduated cylinder down to 900 milliliters by pouring some of it back into the gallon container, and then we'll add it up to 1,000 milliliters with vegetable oil. Okay, we're right at 900 milliliters of stale gasoline, and now I'm going to go get some new canola oil. All right, and the canola oil, I'll take it up to 1,000 milliliters. Okay, right at 1,000. And we'll give it a few moments to equilibrate. In fact, what we can do is measure the viscosity. I'll just dip this up and down a little bit to stir things around a little bit. All right. Let's see what we get. Oops, turbulence. Okay, 10% blend rose to 0.82. Diesel fuel came out at 0.843, so the specific gravity is a little light. But now let's see what we get for viscosity. Okay, 30 seconds, 30.6 seconds for viscosity, which is right on with diesel fuel. So I'm going to run this in my diesel engine with 10% oil to 90% stale gasoline, and we'll see how it goes. To continue our experiment with waste gasoline, remember we determined that if we added vegetable oil at about 10% to the gasoline, or waste gasoline, or stale gasoline actually, then we would end up with a fuel that was about the right consistency or viscosity and specific gravity of diesel fuel. So I went ahead and put the 18 gallons of waste or stale gasoline into my processing tank, and then I poured about 2 gallons of vegetable oil on top, and I let it settle for about 24 to 48 hours. And then before using it, I extracted a sample. I drained off the bottom about a half a gallon, and it started running thinner and lighter colored about halfway into the container. So I just went ahead and filled up the container, and it looked to me as though there was only going to be about a half a gallon of precipitate, which is unusual. Usually there's about 10% precipitate. And then, so I then ran it through my filters and into my engine to run, but I found right away the engine was running rough, and in a very short period of time my secondary fuel filter, which is a 5-micron filter, plugged. At that point, I replaced the filter, and I also just, I guess out of intuition or whatever, I drained off some more of the fluid at the bottom, and I noticed there was more precipitate, and it didn't take long before the fluid started running much thinner. So I noticed that the first sample of fluid I drew off was more viscous, and the final sample I drew off, so this is, let's say, the first half gallon, and this is after about 2.5 gallons went by through my filtering system. So this is so that accounts for 3.5 gallons of blend, and this is the last half gallon of that 3.5 gallons. And I noticed that this was running a lot thinner. So the question arose for me was, is that thick precipitate all the vegetable oil and none of it stale gasoline? So we're going to test these two samples. They look about the same, but I noticed that there's a little bit of water at the bottom of this container. It's also goes through dark. There's definitely, this container is actually darker than this one, even though in this light they look about the same. But what I'll do is I'll zoom in with the camera so you can see the water at the bottom of this container, and we'll look at this one too, and there's really nothing at the bottom of the container. It hasn't been filtered, but it has been settled, and there's this container's been sitting for 2 days. There's no precipitate at the bottom of the container. So let's go see that. And if you can see, there's a light band at the bottom of the container. That light band is water, and then there's a dark layer, and that is precipitate of carbon particles, and then it goes amber up here, but it's thicker than the other container. So now let's look at the second sample from our stale gasoline blending experiment. And as we can see at the bottom of this container, it's actually a light amber colored, and the whole container is in fact this light color, and there's no dark sediment at the bottom and there's no water. So now let's examine the light fraction of the stale gas blend experiment. And that would be this container. It doesn't have the water precipitate at the bottom. I'm going to fill up my 1,000-liter graduated cylinder, and I'm going to test its specific gravity with a hydrometer, and then its viscosity with a Ford VisCup 0. So now I'm going to test the specific gravity of our 90% stale gas blend with 10% vegetable oil, and I'm going to use an 800 to 850 or 0.800 to 0.850 hydrometer. And it doesn't look like it got any more denser than the original stale gasoline, so it could be our vegetable oil passed right through and didn't blend at all. I've got 0.812 on the hydrometer. So checking my notes, it turns out that the viscosity of this substance, stale gas substance, is really only 0.02 of units denser than the original stale gas. So it did not absorb the gasoline, the vegetable oil at all, or hardly at all, probably just a little bit. And now what we're going to do is we're going to test its viscosity with a Ford cup, the number 0 Ford cup. Alright, it came out to 28 seconds, and that is the same time that the stale gas had before we added the vegetable oil. Interestingly, we tested the specific gravity and viscosity maybe 5 or 10 minutes after adding vegetable oil, and we found that the blend was more viscous and had greater specific gravity, but that vegetable oil eventually settled out. It just took a few days for it to do that. So now what we're going to do is we're going to test the precipitate, the more viscous material. It's going to be mostly vegetable oil, but maybe it absorbed some of the stale gasoline. The sample smells like stale gasoline, but it's quite viscous like vegetable oil. So now let's test the specific gravity of our sample. And it's I don't have a hydrometer. I remember now, I don't have a hydrometer that is dense enough to measure the specific gravity of vegetable oil, and the hydrometer is bobbing at about the same height that it would be in straight canola oil. So I think we can conclude at this point that this stuff is mostly canola oil, although it has a trace of enough of a trace of the stale gasoline in it to give it some smell. At this point, we can conclude that at least my sample of stale gasoline is not going to blend with vegetable oil. And now what we could do is keep the stale gasoline around and try blending it with waste motor oil. Perhaps it will blend with that. But it's possible that no stale gasoline will blend with vegetable oil. However, this is too small a sample to make that kind of conclusion. and I'm not going to bother to test the viscosity of this vegetable oil because it's almost 100% vegetable oil, and it explains why my engine did not run well on it, even though the engine was hot. The engine, because it was almost 100% vegetable oil at the bottom of my blending tank. And so I can conclude that that stale gas blending experiment was a bust, and we should move on.